Hello dear student, today we are going to cover hypothesis testing and estimation. Remember last time we did the probability theory, we did probability distribution. So today we are going to cover now, extend the same concept on this. So statistical inference, I know you have the note on this, is the process of using the sample to make a conclusion about the population, as per the note. And there is something that I want to bring to your attention here. Parameter and statistics. A parameter is any statistical measure that is based on the unit from population. Like if you get the mean of the population in a class, to say the entire class, that is parameter. But now when you get the same mean from a sample, it is a statistics. And I want to introduce to you the same that we are going to use when we are talking about parameter. Parameter, they are in your notes. Sample, statistic. When we talk about this, if it is number of items, this one we are going to use capital N, small n. If it is mean or arithmetic mean, this one we shall use the mu, the sign will be that mean. This one we shall use x bar. Proportion, this one we say sigma. Remember the sigma that we have been using, S. Now in case you are talking about standard deviation, this one, proportion, this is pi, p. This is now the one with sigma and standard deviation. So these are the symbols that we are going to interact with in these topics. Please take note of them. And when we talk about, there is something also we say about characteristics of normal distribution. Please you find it in the note I shared with you. When we say sample mean of plus or minus 1.96 standard deviation, it includes the confidence interval of 95%. If we are talking about 95% plus or minus this, if we are talking about 99% plus or minus 2.57, and if we are talking to 90% plus or minus 1.64. So this one we are going to interact with. Actually, I'll let them be here on the wall so that when we talk about characteristics of normal distribution, what we are doing is doing plus or minus 1.696 include 95%. Plus or minus 2.57 include 99%. Remember these are the z-score. The z-score that we are talking about in last week. Now, when we are going to come up with what we call the confidence interval, dense interval. So this is how we do it. For the mean, we always start with the mean. Mean is the common one. Mean, and in this case, is large sample. A large sample is where we assume it is greater than that. A sample of greater than that, we say it is a large sample. And it is given as mean equals to sample mean plus or minus z-score, and z-score can be any of these. Then standard error. The standard error of the mean, this is called the standard error of the mean, is given as s divided by n squared. Sample standard deviation. Remember we are using the sample to make conclusion about population. This is number of items. This z-score applied in we are talking about large sample. For instance, there is a question here I would like to tackle. They were asking the confidence interval for a large sample. So when you do this question, this is April 2023 question number 3, B1. So they are asking, the monthly rate by resident of Houston is found to be normally distributed with a mean given there and standard deviation. On the basis of sample of 200, construct a 95% confidence interval. Remember, this is the mean. For the mean, so you say equals to sample mean is given there. Sample mean is 22,150 plus or minus. We are going to use 95% confidence interval. For 95, we have seen it is 1.96. So 1.96 standard error. So we need to get the standard error. And standard error in this case, maybe we can just first get the standard error to help you understand. Standard error we have said is S over N, which is sample size in this case is 200. As standard deviation is 8900 divided by 200 squared. Divide, you get the answer. So here we are saying, you come and say 8900 divided by square root of 200, you get 629.325. So that means our mean is 22,150. 150 plus or minus 1.96 times this answer, which is standard error, and it may pattern to be 629.325. So multiply now times 1.96. You get mean equals to 22,150 plus or minus 1233.48. So you add, plus means you add, so we can add 22,150. You get 23. So we equalize between 23,383.48 and minus is on this side, which is means you take this minus this. 22,150 minus 1233.48, you get 20. 916.52. So this one we can say at 95% confidence level, we are confident that the population mean, or maybe the monthly rate for the population lies between this figure and this figure. So this is, we just use this formula, the sample mean, the Z-score for a large sample. Large sample is said if N is greater than 30. So for a small sample, I'll show you how we do. So this is the confidence interval, and you'll find more questions on this from the papers. Now, we talk about sample small mean. Of course, you can find the same question was done. Other questions, we have more questions on that. Now, when we talk about the small mean is where we are going to use the t-tables. Small mean. The same formula we apply. These questions are there in the notes. When we are talking about small mean is in the sample size. Smaller sum is less than that. Like in that case, we were talking about 200. 200 is a large sample. If you are given something of less than that, we use the table we call t-table. The same formula we apply. Mean equals to x bar plus or minus t standard error of the mean. So the only thing that we change is badala kutumia z, we now use the t-tables. Like here, we can do a question like December 2021, question number 7a. December 2021, 7a. Now in this question, why are we saying it's some small mean? Because the number was less. If you go back to the, maybe allow me to get to my papers so that we can get clear about this. December 2021. Yes, December 2021, question number 7A. 7A. A random sample of 15 employees. Now you can see this 15 is less than 30. Of a call center was taken and each employee took a competent test. The mean score achieved by them, which is our mean score, is 56 with a standard deviation of 7.1. The results have been found to be normally distributed. So we are using the t-table. This is a small sample. So we are going to say the standard error in this case is n over square root of this one. So S in this case is the sample standard deviation of 7.1 divided by 15 squared. You get the same S. So you say 15 divided by 7.1 divided by square root of 15. We get 1.83. So now you say mean equals to, sample mean we are given there to be 56.3 plus or minus. Now the t table, when you go to our t, you find in our table we have given the t tables there in your past papers. There now there is something written there, the confidence level. Like in this case we are using 95. You will find them there in the t tables. There down there is confidence interval. We need to get the degree of freedom. Degree of freedom is given as n minus 1. N, like in this case, was 15 minus 1, you get 14. So you now check 95 there down against df and written. On your left hand side, you see something df. Df is the degree of freedom. So 95 against 14, you get 2.145. So you say 2.145 times 1.83. What? So where is this 2.15? We are using the t table because t table apply when we are talking about less than 30 items, like in this case. So we are saying 95 df against 14. So we get this, then we get the range of the mean, and after calculating that, we are going to see that to be the same as, it will lie between 71.53% minus 41.7%. So because this will be 56.3 plus 15.3. So remember, here we are using the t because this is a small sample. But if it is large sample, we are talking about greater than 30. We are going, if it is 95, 1.96. If it is 99, 2.57. We are going to have more questions on this, and please these questions are solved in your papers. In the case we are not given the standard deviation, like we are not given S, there is a formula in the one on how to get X, how to get this S, how to get the mean if they are not given. Hope that is clear. Now when we talk about the test of hypothesis, please, there are some more to go there. Test of hypothesis. What are the procedure of doing it? There is null and alternative hypothesis. Please, you can go through those notes. We may not discuss them in details. But of course, I will show you how to test hypothesis for a large sample. Testing hypothesis for large sample. Actually, we are going to go much of the same. Now, when we come to test, this was the confidence interval, which is estimation. Now, when we come to testing hypothesis, we can have, just like in that case, large sample and small sample. So in this case, we test hypothesis for large sample. Large sample, we start with what we call population mean. Population mean. Actually, we are going to measure the population mean because that's the most of the questions that goes that. So the procedure of doing this, you state the null and alternative hypothesis, then the level of significance, and please you need to know if confidence interval is 95%, then significance level is 5%. Please you need to know that. Confidence interval of 5%, and this is where we are saying 1.196 plus or minus. If it is 99, significance level is 1. So this is what we are saying 2.57. If it is 90, significance level will be 10%. And this is the one we are saying plus or minus 1.64. Please note that. Then of course you make a conclusion. If I take you back to the same question we were doing, now to test hypothesis. This was testing hypothesis. If we are to go and do the descent, April 2023, question 3B, Roman 2. Please take note of this. We are told the monthly rent, this is the same question we have done there for part 1. This is large sample, it's 200. Test hypothesis that the amount paid is 20,000, 5% significant level, part 2. So we are saying now hypothesis, is the one which agreed with the claim that mean of the population is 20,000. Alternative, now remember there is none hypothesis, we write it as HO, and alternative which go contrary to that. Mean is not 20,000. So this one we say mean is 20,000, mean is not 20,000. Significance level written as this. If you go through the note, write it as this is 5%. Z test for a single mean, so this is just one mean, population mean alone. It's X minus mean divided by the standard error. Remember, I'm showing you how to get the standard error from that discussion. So you come and say, in this case, you come and say, so this is the formula, Z test, according to the procedure we are saying there. So this is Z equals to X, the sample mean was 22. So this one we are saying X sample mean. So the mean there is, this is hypothetical mean. Please take note, hypothetical mean. This portion is the standard error. So here we are saying 22, 150 minus hypothetical mean is the one we are saying 20,000 divided by the standard error, which is standard deviation was 8,900 divided by 200 squared. I think we did this question in class understood. Let me check. Yeah, we did it to kapata 3.42. Remember, we are saying at 5%. So at 5%, remember that if you are using the two-tailed test, it is between negative 1.96 and positive 1.96. Please take note of that. So we ask ourselves, this is called acceptance region, the one which is not shaded. The shaded one is rejection. What is this 3.42? It is greater than 1.96, and therefore it will be rejection. So you come and say reject null hypothesis. Thus, you now agree with the second statement. Why are we rejecting? Because this 3.42 is not within this range of accepting. If it was within the range, we could have accepted. But now this is reject, and therefore the claim that so thus the amount paid in monthly rent is not, or you can use your own language, is not 20,000. So otherwise, if we could have accepted, we would have agreed with the null hypothesis. This is called the null hypothesis, alternative hypothesis. Every time you are doing hypothesis, you always start from here. Null hypothesis, alternative hypothesis. So this is for a single mean, and of course we are going to find other questions on this. So the step number 1 stage of hypothesis, null and alternative significance level, Z test for a single mean. So this is the procedure, you get this, then you use two-tailed. If you go through the note, you get the explanation. 5%, we say it's not in this range, you reject. So I hope that is clear about, we are still in the large sample. What about difference between two means? The procedure will be the same, but number B, difference between two means or average. Between. Still, this one you find it in your notes. The procedure will be the same, but now the Z test will be given as the mean, the first mean minus the second mean. Here there are two means, standard deviation plus S2 squared divided by N2. So the standard deviation of the first one, standard deviation of the second mean. Like in this case, there is a question given. Maybe you can do December 2022. Let us December 2022 question 4a. I can take you short to do that. December 2022 question 4a. We are not going to do many questions on that. December 2022 4a. So now December 2022 question 4a. So this question ilikuwa inasema, and this is large sample. Large sample should be above 30. The production manager is investigating the claim by customer about machine A and machine B that it manufactures. The claim is that machine A has longer useful life than B. A sample of 60 is greater than 30, taken from market review that machine A has useful life of 28,000 with standard deviation of 900. A sample of 80 taken from B was found to have useful life of 30,000 hours with the standard deviation of 1,000. And advise the production manager if there is any significant difference in the useful life. So now hypothesis here we should state the useful life of A equals to useful life of B. No significant difference. Alternative hypothesis of A is not of B, which means there is a significant difference. So that is 5%. These are the two means. Please, you need to understand. We are talking about the two means in our case. Therefore, if you come to this side, two means. Z test we have said is there. We can write it again. x1 minus x2 divided by plus s2 squared divided by n2 squared, which is the sample mean of the first one. The mean of the first one we have said A, which is 28,000 minus 30,000 divided by standard deviation is square. So standard deviation of machine A is 900 squared divided by 60 plus the B is 1,000 square divided by 80, then you get the square root. If you want this out, you will find it is negative 12.40. Use the two table. Remember we are using 5%, which is plus or minus 9.6. Plus or minus. So where is this? This is still in the rejection. Remember we said shaded is the rejection. If our value falls in the shaded, we reject, but unshaded is the acceptance. Like in this case, you say reject null hypothesis because negative 12.40 is in the rejection. Acceptance is if it falls in within this range. So we can say there is significant difference. Reject. Therefore, there is significant difference in the useful life of machine. Remember, if you reject, you agree with the other statement that there is significant difference. So that is in the case of difference between two means. Now, what about now for small sample? That is large sample. There is proportion. I know you can go and pour out the other procedure. When we talk about proportion, small mean. Small mean, I can show you now for small sample. And this one we are just going to talk about the mean, the small sample. Small sample is if it is less than that. Small sample. The procedure will be the same. We start with population mean. Please, the others you can go and read. So the procedure will be the same. The only thing that will change is T. T will be sample mean divided by standard error. You can see the same as Z, but now here we are going to use T table. It's a small small sample. And in case we are not given the standard deviation, the formula is summation x divided by n minus 1. N minus 1 is the degree of freedom. Please take note of that, degree of freedom. Like there is this question that was given in our scenario, August 2023 7b. Just to show you how we are doing it. August 2023 7b. So this is now testing hypothesis. Please, I'm summarizing because you know that August 2023, or we can get another question here, which is not part of that. Now, in case you are not given the standard deviation, please you need to calculate them. Sometimes you will not be given the standard deviation, so your work is just to calculate them. Or a different question from that. Let me see whether we can get one. You can see I don't have 7b in my paper. So maybe we can just what the difference here, the procedure will be the same. Or just looking for a question which is simple, but of course I may not find it there. But the difference, as you can see that question, you follow the same procedure. There was the mean was, that is now August 2023 7b. Null hypothesis, mean was 2 is equals to 400. Alternative, mean is not equals to 400. So we are testing to find out whether mean is 400. So T is x minus mean was given squared. So this one is sample mean was given as 407. Hypothetical is this one divided by standard error 6/12 squared, which you get 4.04. Now for this one, if it is less, remember our sample size is less than 30. So in this case, what we do, please take note of this. What we do, we use the t-table. The t-table, and we are going to use the two tables. The t-tables are in our tables. You go to where we have the t-table, like I have mine. So we are using the significance level we were told is 5%. Yes, 5%. So the degree of freedom is n minus 1, 12 minus 1. So you go to where we have two tables. At the top, there are one tail, two tails, which is 0.05. 0.05 against the degree of freedom is 11. 0.5 kuangalia mahali kuna two tables, then against 11. Unapata ni 2 point, negative 2, like this one. If it is 1%, this was 1%. This was 1%, sorry. We were using 99 confidence level or 1%. So you go and get the 0.01 is 2 tail against 11. You get 3.1. So you come and say here, negative 3 point. This is 3 against 11. 0.01 against 11. 106. So for t-table, see come at the z tables where we can use 1.96, 2.57. Here we have to get the degree of freedom and use the 2 table plus 3.106. Then like this one follows in the rejection. So you say reject the null hypothesis. So you reject the null hypothesis as shown in the notes I shared with you. Reject null hypothesis. Thus, if you reject this, then you agree with this. Thus, then mean is not 400. Please take note of that. It's not 400. There are other questions we did. If the mean is not given, like May 2017, we were not given the mean. Mean we always say x bar summation x divided by n. So you need to calculate it. If you follow that question, we can show how to calculate the standard deviation, how to get them, and then use our questions. Lastly, if it is difference between two means, the last three, difference between two mean. For small sample, that is, difference between two means. For smaller sample, and remember we are saying smaller sample, the mean is, the sample size is less than that. So here we see the same formula, T x minus divided by the standard error of the mean. Standard error of the mean, and that standard error of the mean is given as n minus 1, n1 minus 1, s1 square, plus n2 minus 1, s2 square, divided by n plus n2 minus 2. This is called the degree of freedom. Then you get there. So that is, it will give us, so maybe before we get to this, we say that one will be given s times n1, n2 divided by n1, n2. This is the combined standard deviation. This combined standard deviation is n1 minus 1, s1 square plus n2 minus 1, s2 square divided by n1 plus n2 minus 2. The denominator is called the degree of freedom. This is the degree of freedom. Please take note of that. Now, like in this question, which we can do when we write up, December 2021, November 2020, question 1b, higher. If you go to that question, November 2020, so this question we were given, the daytime student and evening time student, and we are told to find out whether there is significant difference in the performance of the daytime and evening student. So our null hypothesis, the mean of the daytime is equal to the mean of evening, which means there is no significant difference. Alternative is now D equals to B evening, so there is significant difference. Test of significance we were told to be 5%. So T, we are using T because if you get the total of the daytime, which is 13, and evening 15 is less than that. So that's why we are using the T table. So we use this formula, x1, x2, the mean of x1. x1 is the day, evening, divided by. So now this x, we are saying is s times n1 plus n2 divided by n1, n2. And this s is n1, s1 square plus n2 divided by n1 plus n2 minus 2, the degree of freedom. So we come here, we start with this one. S equals the total of the daytime is 13. So 13 minus 1, 4 squared, the standard deviation of the first mean, plus 15 minus 1. The standard deviation is 5 squared divided by 13 plus 15 minus 2. So this one, pattern 4.57. Remember, this is, if it is variance, you don't square. Then, so that means S standard error equals to 4.57 times N1, which is 13 times 15, 13 plus 15, 28, divided by 195 squared. you get to be 1.73. So now what will be t? T is mean of the daytime was 45, mean of the evening was 55 divided by the standard error of the mean, which is 1.73. You get negative 5.78. So use the two tables. Now, what is the degree of freedom in this case? Degree of freedom is what we have here, 15 plus 13 minus 2. So you go to the t tables. Our t tables is given there. You check the 0.05, 2 tables per 2. Remember per 2 we are t table to 1 table, 2 table. 2 table which is 0.05 against 13 plus 15, 28 minus 2, 26 against 26. 0.05 against 26, you get 2.056 negative. Negative 2.056 plus 2.056. You calculate and get the answer. So you now see this one is going to be rejected because it doesn't rise between the acceptance. So reject, thus there is significance difference. And please, if you are not given the mean, you need to calculate the mean. Like you get the mean of the first one, the mean of the second one. So this is for the sample mean. If it is large mean, don't confuse. Large mean is when n is greater than 30. We say my z test is x1, x2, s1 square over n1 plus s2 square. Please don't confuse when we talk about small. And please, I want you to go. You can see there is a question you are doing there, student. Chi-square, I want you to go and read. It's not very hard. Actually, it is only 2 pages. Please go through the chi-square, read at your own time. Maybe I can only take through, but if there is a concept you can read and understand on your own, is the chi-square. We have the table of chi-square in our past papers, so you can see how to use the chi-square. Now, in case you need my help, I can always come to that, but I wish to stop at that point. So in the coming class, we shall be doing correlation and regression analysis. So I have explained my concept. If anything is not clear, always come back to me and I'll help you. Thank you so much.